My name is Jagadish Shukla. I am a distinguished university professor emeritus in George Mason University in the Department of Atmosphere, Ocean and Earth Sciences. This is the department that I helped establish many years ago, and also the Climate Dynamics PhD program at George Mason, which has produced more than 60 PhDs. I am a researcher, basically. I do teach undergraduate and graduate classes, but my main research is on predictability of weather and climate. Why there are limits to prediction? How can we improve the prediction? And I'm involved with several international and national organizations. I received the International Meteorological Organization's prize, which is given to one person each year. I also am a member of India's Prime Minister's Council on Climate Change, and I was also a member of the Virginia Governor's Commission on Climate Change. So I had very modest beginnings. I was born in a very backward, small village in eastern UP in India. This village had no school, so my primary education was under a banyan tree. The middle school I had to walk barefoot for 3 miles, and high school I had to walk to another school which has no science. But somehow my father was so insistent that I should study science that after I graduated from 10th grade, he brought me all the books for 6, 7, 8, 9, 10 and asked me to study. And then there was a test I passed. That's how I got into science. My real interest in science started much later because I wanted to predict Indian monsoon, because that's what I had experienced in my village. Monsoon droughts, monsoon floods were the biggest problem in the village, in the villagers. And I wanted to understand and see if we can predict better. So first opportunity I got to come to MIT to do research, I came. The very first thing that affected me from my childhood was this great inequality and poverty. See, I am not from a rich family, but I was not the poorest man. My father had actually a job. He actually teach in a middle school. But there was just so much inequality and poverty. And the suffering was very much based on how monsoon is doing if there is a drought. So that actually became one of the guiding principles when finally I said, okay, what am I going to do? I chose. But as you will find in the memoir, I got by accident into weather and climate field. I was working in an oil rig, and I just had applied for some job in the weather department, and I got an interview. And I went into the interview, and I was very relaxed about any questions they will ask me. And then I got selected. It was pretty good, high position. It's called Junior Scientific Officer. This is when I was 21 years old. And I got this very good government job. In India, in a government job at that time means there will be a person sitting outside your office, bringing you water, bringing you tea, giving it. But I was not satisfied with my knowledge about meteorology. So I happened to meet this famous MIT professor, Jules Charney, because India had sent me into a meeting. And I said, okay, I will go to MIT and study. And he changed my life in many ways, because being ignorant of his work, my presentation was criticizing what he had done. And everybody was stunned. Who is this kid from India? Because he was the greatest man in meteorology. Everybody knew that, except me, because I was not in meteorology, I was just sent. He came to me after my presentation. Here I thought, oh my God, what he's going to ask? And he asked me to read some more papers. I immediately wrote to him. And that's how I got to MIT. So just let's be clear about the difference between weather prediction, which is day-to-day weather for 10 days, 12 days. There we predict sequence of weather. Today it will happen this, 12 hours, 24 hours, and so on. Seasonal prediction is what to predict about the average over the season. Is this season going to be dry or wet? Is it going to be warm or cold? So my work was on seasonal prediction. And when I started this work, nobody actually believed it. I really thought because the butterfly effect was such a dominant paradigm that it created that impression that nothing is predictable beyond 10 days. So I talked to the professor who was there at MIT and my own professor, who is also very famous, Jules Charney, and both of them said, look, we never said that seasonal mean is not predictable. That's what people assumed because of the butterfly effect. So it's a good problem to work on, and that's what I did. I worked on and I showed, and the most gratifying thing is that after working on that problem for 8 years or so, another scientist, another fellow scientist from MIT, another student, my friend, he showed that how the ocean itself can be predicted. So if you combine these things, we really established a real scientific basis for seasonal prediction. There was no seasonal prediction by using these complex models before that. People were doing seasonal prediction, but they were using regressions, statistics, use the past data. Now, seasonal prediction by using these complex climate models has become a routine. It is saving lives, it is saving property. A lot of countries in the world which are affected by seasonal climate are using this forecast to decide what kind of plants to seed, seeds to put, what kind of, because they can know, they have an idea, is it going to be rain or drought? So I think it has helped a lot to the whole world that now we have seasonal prediction produced objectively by supercomputers and mathematical models, just like we were predicting weather first for 10 days. Most of the people know that butterfly effect means that the weather cannot be predicted beyond a few days. In fact, it has a deeper meaning. The meaning of the butterfly effect is that if you make a small change in your initial condition, the system can give you very different outcomes after some time. This was done by a professor at MIT who happened to be one of my advisors. And he wrote a kind of an interesting title, How a Butterfly in Brazil Can Change Tornadoes in Texas. But his original paper was about seagulls. All he wanted to say that was how seagulls somewhere will change weather somewhere else. But when his results were presented, one of his figures looked like a butterfly effect, butterfly. So the guy who was organizing the meeting in Washington, he asked him, can we change the title of your paper to how the butterflies change from seagull to butterfly? He never got the message. This guy changed it anyway. So now everybody knows about butterfly effect, but that's not what Lorraine initially intended. So my involvement with the butterfly effect is really very unusual. I had never heard of the butterfly effect until I came to MIT as a graduate student. So this was a big problem for me because I came to MIT to predict monsoon. Monsoon means I wanted to predict seasonal monsoon. I come to MIT and I find out that butterfly effect, which everybody talked about it, because that professor is there at MIT, means you cannot predict things beyond 10 days. And at that moment, I thought, okay, as soon as I finish my PhD, I'm going to try to work on how to show that in spite of the butterfly effect, seasonal mean can be predicted. And that's the essence of my research. And the reason the book title is A Billion Butterfly Effect, because I did an experiment with a climate model and showed that normally what is done is perturb the initial condition very little, as if butterflies flapping their wing. I said, no, I will disturb the initial condition by billions of butterflies. What do I mean by billions of butterflies? I mean, I will not make a small change in the initial condition, I'll make a big change. And then I showed nothing happened. So how did that happen? The reason it happened is because the ocean was so important, which was not being considered before while talking about butterfly effect. People were just talking about weather. My main contribution was to show that the ocean can be so dominant effect that billions of butterflies cannot change what the ocean is going to do. And that's why we have very good confidence in predicting what will happen to seasonal mean during El Nino. This El Nino is when the Eastern Pacific gets warm or cold. That's one example. And that's one of the most important results we got, that monsoon is predictable, not always, but certainly when the El Nino is very strong in the Pacific. See, the recognition, the whole idea of seasonal prediction, and then the center was created to demonstrate and show that there is a predictability, was the recognition that weather depends upon weather today. That's why it is so sensitive to butterfly effect. But seasonal average doesn't depend just upon today, what is happening. It depends upon what land is doing. Is land is wet or dry? Or there a lot of vegetation or less vegetation? It depends upon what ocean is doing. Is the ocean very warm or very cold? So that's why we had named it Center for Ocean, Land, Atmosphere Studies, the one at George Mason, because it is the interaction between the atmosphere, ocean, and land that produces this seasonal climate. Before that, for weather, we're just interested in weather today, because weather tomorrow almost completely depends upon weather today, but not climate, not seasonal mean. While I'm telling you that, maybe I should also add that while seasonal prediction is different than weather, climate prediction, climate change prediction, is still very different from seasonal prediction. Because now the climate change prediction doesn't just depend upon the ocean and land and atmosphere, it also depends upon how much carbon dioxide we are putting into the atmosphere. And that's the problem that we have been engaged with. And IPCC, the IPCC that actually received the Nobel Peace Prize, along with Vice President Gore, in 2007, of which I was one of the lead authors. For the first time, we could claim that human activities are causing climate change. It's such a big thing to say, that we humans can change the whole climate of the earth. But we had models, we had data to show, and when Paris Climate Conference took place, 200 countries in the world came and they all agreed. And they all decided to cut down their emissions. Unfortunately, we in USA are not doing it. And that's a different story, because when the first time when Mr. Trump was elected, he got us out of this climate change, okay? And then we were out of Paris Agreement for 4 years. Then Mr. Biden, President Biden, got us in. And we're working on a lot of things, how to cut down, how to mitigate, how to adapt. Mr. Trump came again, now he has taken us out of the climate change. So the beautiful scientific problem, challenging scientifically, also helping society, has now become a political element based on politics and ideology. That's just tragedy, and we just have to face it. There's nothing we can do about it. So let's put it in 3 classes. Weather research. What is the most pressing thing in weather? By weather, I mean forecast for 10 days and 15 days. I think the most pressing thing is to predict extreme events. There's a heavy rainfall, there's a huge storm. These are within 10-day to 14-day. Okay, we have to be able to model and predict them. In seasonal time scale, the most pressing issue is to be able to make better seasonal prediction, improve our models, and understand and model better how the ocean affects, how the land affects, how the snowfall affects, how the snow affects, how the sea ice affects. All these things which change slowly compared to weather, they all affect seasonal. That's the biggest challenge now. And of course, how to convey that information to society. This is what will happen. And in the climate change, the most important thing is to be able to predict regional climate. We have already predicted global mean temperature will happen. increase. But nobody feels global mean temperature, right? It is the local temperature. And by the way, when global mean temperature changes by 2 degrees, 1 degree, that means a regional temperature, say at Phoenix, Arizona, you will have hundreds, more than 100 degrees days. So this global small number, that's just like feeling, you have fever. Just like say, oh, you have a fever. Doesn't say anything about why you have a fever, what is happening. So this is our challenge now, is to not just say global mean temperature, but what will happen regionally. How can we say, okay, what will happen at Virginia? What will happen in Fairfax? And we actually, our group and Dr. Kinter, who is the director, we have now created a new second center. It is called Virginia Climate Center, which is working on this problem of finding out predictions as well as adaptation and mitigation approaches for Virginia. Well, this is not just my village, but my work was on seasonal prediction, which has helped the entire world which are interested in. But it particularly has helped those countries which is affected greatly by the ocean temperature, like the Pacific. For example, South American coast, okay? So our seasonal predictions are better now. Before this seasonal prediction, these farmers had no basis to go anywhere. So I'll say that the ability of the farmers in my village, so like in the other villages, has greatly improved to decide what to do with their agriculture practices. They're always asking me whenever I go. I always go to my village. For the last 50 years, I've gone to every year. And of course, the reason I go is because my wife and I have created a school, as you'll see in a minute, for girls, because I find that the girls had no opportunity to study. So I do go there, and it just feels good, very good, because the same girls who didn't have any opportunity, they really feel empowered. I've heard their debate. They are, debating against the dowry system. They are debating, they're about personal hygiene. So it's very slow, very little, but it's in the positive direction, and you just feel satisfied about doing something. So I think it says more about my personal attitude in life. I'm just an optimistic person. And just because some people were saying butterfly effect means you cannot predict things beyond 10 days, I didn't take it. I said that, and I feel that in this world, we emphasize too much on chaos and very little on predictability in the midst of chaos. Yes, there is chaotic components, and our mathematical equations are chaotic, but the world has far more order than chaos. I mean, look at it may feel like, oh, no, we're in a big chaos. We're not. So I'm one of those people who thinks that world has made a lot of progress and is continuing to make progress. In every area, we have made in health, we have made in predictions, we have made in transportation, we have made in travel, medicine, quality of life, longevity, everything we have made, okay? So it's not the property of a chaotic system. So there is predictability on this. And I always like to emphasize on that. I think what people feel overwhelmed is that the climate change one, particularly, let me tell you, and this is a problem in USA more than anywhere else. There are so many forces which are constantly trying to misinform the public. Oh, no, it's not real. It's not important. Oh, no, we'll know how to manage. So therefore, most of the people are not sure. They don't believe. Or they say, oh, there are two different opinions. This is what happened in a democracy. As soon as you have two opinions, the population is divided 50-50. And then at the top of that, we have a political system where the fossil fuel industry definitely doesn't want any regulations which will change their consumption. So the greed has come into the picture. And the future of humankind is actually truly in danger. Let me tell you. I mean, I know it may sound like exaggeration. What I meant by in danger? We're not going to disappear from this earth, but we'll have far more diseases. We'll have far more floods. We'll have far more hunger. And so it is really the poor people who will suffer the most. And they are the ones who contribute the least to the problem, right? And I tell you, my personal big kind of mystery I cannot understand. All these leaders of fossil fuel industries, all these leaders of political system who are really not taking any action, they also have children, right? They have grandchildren. Are they not concerned? So it's but this is not the problem worldwide. Most of the people, I go to India, I go to Europe a lot, and in fact, it is this big sort of disappointment and lack of understanding why I organized this letter by 20 scientists to President Obama. And you'll see in memoir, they went after me. They went after me, they investigated every grant I had received, every grant, every detail, every paycheck, and they didn't find anything. So it was painful, and the congressman who was doing it, he then finally decided to retire. So, I mean, it's a big satisfaction that the system works, but somebody has to pay the price. And I have always maintained to my scientific colleagues, this is a small price to pay to defend the integrity of science. We have to constantly defend the integrity of science. We cannot just give up. And I tell that to my students. I teach undergraduate class. Many of them say, oh, we have so much anxiety about climate change. They feel overwhelmed. And in fact, part of it was my fault and my co-teacher's fault. We kept emphasizing the impacts. This will happen, that will happen, this will happen. And they started saying, Professor, I'm really feeling anxiety. I changed my course, by the way. It's Climb 101 that I teach here. I changed my course and put several lectures on hopeful signs for climate change. Because there are all a lot of hopeful signs. All these agreements the countries are making to cut down their emissions. All the decisions that countries have made to be able to, help reduce the emissions. And I tell the students, the solution to climate anxiety is climate action. The only region internationally and in WMO we are having a success in getting some things done is the protests by the young people. Young people all over the world are protesting. And they did. You must have heard Thunberg. She became so many young people, and that made a difference. And that has to continue, because that's the only way the policymakers will get a message. Otherwise, the only thing they hear from is from their donors and their lobbyists. If there is one message I want people to get, and especially the young people, that don't underestimate the power you have within you to make a difference. You can change things. You just don't feel helpless. You can change things. And I think that all my book is filled with examples. I didn't give up. And I came from a poor family. I came from a backward area and so on. But I didn't give up. And there were many places which I claim I did succeed in making a difference. So I want all these young people, particularly the young people in rural and backward and poor countries that you can do something. And the system helps you. There are people, there are institutions who will help you. I don't want people to get disappointed and just give up before trying. And if you try and fail, you are much better off than not try and succeed. I believed in living this place a better place, living this world a better place. I strongly believe in that, okay? And I feel we should apply that everywhere. We are at a place, at a university, we are in a meeting, you are at a restaurant for dining, and so on. Just live it better than when you came in. And that has sort of guided me in same way, whether it is my village or whether it is the university or whether it's a conference that I'm attending.